Hi, my name is Lyndon Liang,
I'm Vi Kadambi.
and we're the Statsbusters. So today we're going to be predicting the growth rate of YouTube videos.
Awesome. So as we all know, YouTube is such a relevant part of our lives, and YouTube is also a business. So YouTubers want to monetize their videos and optimize the views they get. So our goal here is to predict the percentage change in views on a video between the second and sixth hour since its publishing, using features such as thumbnail image, video title, and channel, and others.
Right, so to begin, we're going to be talking about our model type and how we picked it. Following that, we're going to talk about how we found our optimal variables. And then next, we're going to talk about extracting values from the published date variable. And finally, we're going to discuss our most prevalent problem in our model.
Awesome. So to pick our bagging model, we first looked at a linear model and picked the subset of predictors using correlation and transformed these predictors. But our linear model didn't end up working because our data was too complex and violated all the assumptions that a linear model makes. To deal with this, we decided to shift to a tree-based model, since trees allow us to flexibly fit unstructured data without making any assumptions on the data. And we tried random forest bagging and boosting, and our bagging model gave us the lowest RMSE score, so we went with that.
Right, so following that, to pick our optimal variables, we began using correlation. However, this did not work very well because our variables were not well correlated with our response variable, and we did not consider multicollinearity in the end because we were not using a linear model. So we ended up using forward selection to find our best subset of variables, and it ended up being that 200 variables provide us with the lowest RMSE with our bagging model.
Awesome. So lastly, we transformed the published date variable since time data is so essential to this problem. And we extracted the month, day of the week, time of the day, etc., from the published date predictor to put this value back into our bagging model. We saw a lot of different trends. For example, we saw that when you look at the month published versus the percentage of growth, it's a lot higher in the summer months rather than the months before and after.
Right, so next, our most prevalent problem is that our predictions were ranging from 0 to 8, while our training data response variable was really ranging from 0 to 10. And this was mostly happening because a bagging model tends to shift predictions away from extreme values towards the mean. So we tried to solve this problem by combining our bagging model with an OLS model in various different ways, and none of them seemed to work very well.
So just to recap, our final model consisted of a tree-based bagging model with its optimal subset being having 200 predictors. We included the time data from the published date variable and did not include any other numerical transformations. Lastly, we were unable to optimize our model by combining it with an OLS model.
Right, so in conclusion, our model did relatively well because bagging is a non-parametric model that works really well with unstructured data. And we used forward selection to choose our predictors. And lastly, we transformed the published date variable to provide our model with extremely valuable data. However, our model was limited by the fact that bagging narrows extreme values close to the mean, as I mentioned before. However, in the future, we could learn about models that do not shrink predictions towards the center, while also working well with unstructured data like how we had here. Now, additionally, we could also find models other than linear model, which can predict beyond the limits of the bagging model shrinking aspects.
Awesome, guys. This is our presentation. We hope you enjoyed it.